This is our final transformation for this unit. Next, we will start applying multiple transformations to single objects. So in this lesson on dilations, we are going to learn to dilate a figure with a scale factor on the coordinate plane. We will also learn how to find the scale factor of a dilation of a figure. The key information that I want you to remember in this lesson, that's going to be the essential piece that you need to know. To graph, you multiply the coordinates of each point by the scale factor that's given. Okay, so let's take a look at how that works. So in this example, a triangle has vertices A being 0, 0, B being 8, 0, and C being 3, negative 2. Find the coordinates of the triangle after a dilation with a scale factor of 4. So here's the key piece of information. The scale factor is 4. So we're going to take each of these coordinates and multiply the coordinates by 4. And if you like to use notation to keep in mind, you're going to take your xy coordinates, you're going to multiply each x by 4 and each y by 4. Okay? So how does that look? So you take a 0, 0, you multiply x, which is 4 times 0, and y, which is 4 by 0, and you get 0, 0, because anything times 0 is 0. B, same thing. You take the coordinates 8, 0, and you're going to transform them by taking your 4, which is the scale factor, times your x, and your 4 of a scale factor times your y. So you get the new dilated 32, 0. Because 4 times 8 is 32, and 4 times 0 is 0. You do the same thing, and you get, so to point C, 3, negative 2, you're going to multiply the x by 4, because that's our scale factor, and the y by negative 2, and your scale factor of 4. So you get the new coordinate 12, negative 8. So the coordinates after the dilation are A prime is 0, 0, B prime is 32, 0, and C prime is 12, negative 8. Okay. So this is creating your dilation. So a couple things that I want you to realize. If you are doing a scale factor of 4, that means it's increasing in size by a factor of 4. So a scale factor of 4 means it's increasing, it's an enlargement. If you had a scale factor of a fraction, that would mean it's getting smaller. It's like if you had this fraction 1/2, it would be getting smaller. So let's take a look at that. There's a lot of notations that can come along with enlargements and reductions. So on a dilation, if it's going to grow, it means it's an enlargement. It's getting bigger. So if your scale factor, and we often call it K, is greater than 1, then the image that you start with is growing bigger. Now, a reduction is of an image if it's smaller if your K is between 0 and 1. So that's where if it's a fraction. So I like to think of reductions oftentimes as fractions. Usually they're like 1/4 or 1/2 or 1/3. So you're thinking of, okay, if I have my original and I reduce it by a half, it's going to get smaller. So your reductions, your scale factor is going to be fractional because it's going to get smaller. Okay, go ahead and practice this one. I want you to work. Okay, scratch that last example. We're going to try something different. We're going to look at this example. It says graph the image of triangle EFG after the dilation with a scale factor of 5. Centered at the origin. Okay, that's important that we're just centering at the origin, which is what we're going to stay with today. So that allows us to just focus on our coordinates. So first thing we need to do is figure out the coordinates for each of the points on this triangle. So go ahead and take a second and write down those coordinates for each point. And then I want you to double check that you have it correct. Okay, feel free to pause. So you should have gotten the point for F, 0, 1, for G, negative 1, negative 2, for E, 0, negative 2. Now we have to apply our scale factor. Scale factor of 5 tells me that it's going to increase, it's going to enlarge at a rate of 5. So each x and each y, we're going to multiply by 5. So I'm going to say, in order to get my f prime, so I'm going to take 0 times 5 for my x, which 0 times 5 is 0. So I'm creating f prime. And then I'm taking 1 times 5 to get 5 for my y value. Okay, so you're taking your scale factor, whatever it might be, and multiplying it by x and y. So f prime is going to land at 0, 5. So over 0, up 5. So there's 4, 5, put a point, label it f prime. So g prime, I'm going to take the x of -1, multiply that by 5, so that I'm getting g prime is going to come -1 times 5 is -5. Okay, next you're going to take your y, -2, times the scale factor of 5. -2 times 5 is -10, and then we're going to plot that point. So -5, -10. So -5, -10, plot a point. And then we're going to label it G1. Go ahead and pause and figure out what the coordinates of E's image would be. So you're figuring out what E prime is. Unpause once you have that. Okay, so in order to find that, you would have taken 0 times your scale factor, which gives you your x value of 0, and -2 times your scale factor of 5, which is -10. Okay, so I have 0, -10 over 0, down 10, plot a point, label it with my E prime, and then I would connect my points. So double check your work and see that you got that triangle. Okay, so this is all about applying the scale factor to each x and each y. Let's look at another example. We're going to graph the image of triangle KLM. So here's our triangle KLM with a dilation of 1/3 centered around the origin. Okay, so if we look, our scale factor is 1/3. That should immediately tell us that we are going to make this triangle 1/3 of the size that it already is. So we're going to start by writing down our coordinates for each point. Go ahead and pause and write those down. I do want you practicing coming up with coordinates, okay? So write those coordinates down. Double check your points. Make sure that you came up with the same location for each coordinate as I did. And the next thing you need to do is apply your scale factor of 1/3 to each x and each y in order to find your image location. So we're going to take our x of 3, multiply it by our scale factor of 1/3, and I'm going to go ahead and write that down. Okay, so if I take my 1/3 and multiply it times my x value and my 1/3 scale factor times my y value, 1/3 of 3 is 1. 1/3 times 3 is 1. 1/3 of 9 is 3. Okay, so my new points for L prime are 1, 3. So over 1, up 3. I get L prime. On the next one, we're going to take our scale factor of 1/3 and multiply it times the x, so -6 times 1/3. So 1/3 of 6 is -2. Go ahead and fill that into your coordinate. And then I'm going to take my y value of 3 times 1/3. 1/3 of 3 is 1. Do the same thing to coordinate k. So -9 times 1/3. 1/3 of -9 is -3. And I have 9 times 1/3, which is 3. So now I have my points for each of the points on my triangle. So I have L prime, which is at 1, 3. I have M, which is at -2, 1. I'm going to label each one M prime. And I'm going to label K, -3, up 3. Oh, let's keep going there. And I get K prime. Connect my dots. And I have my dilated triangle with a scale factor of 1/3 coming from the origin. All right, let's look at what we need to do. So those of you that are remote, I'm now going to take you in to look at your IXL assignment. If you're remote, you are doing IXL.com. And want you to log in using your username and password. If you don't know it yet, please reach out to me. You should have been logging in the last couple of days. And then press sign in. Once you get in there, please make sure you're on the learning section. Once you're on the learning section, you'll see that you have a gold star pop up. Those are the skills that I would like you to do. The last 2 that you were assigned, you should already have a gold star, a gold medal next to it. That shows you that you completed it. You can also check in Tiger View to see that you have completed your assignments as well. I will update those usually each morning by 10:30. Next, so today's assignment is Dilations, graph the image. So get in here, click on there. You have directions that tell you to look for a scale factor of 2 centered around the origin. Remember, your goal is to get a SMART score of 80. The time does not make any difference to me. I am not watching your time at all that you're spending on there. It's just, I will say, if you're spending over 30 minutes and you're not getting them correct, please reach out. There are learning examples in here, so if you get stuck and you need additional help, learning example here. Otherwise, you make sure you are writing down your coordinates. Start by writing them down. No, there's not a spot for them here, but there will be on the test. So make sure you're starting with your coordinates and applying the scale factor. So in this case, we would multiply by 2 to each of those coordinates. And then you submit and you're going to get feedback saying whether you're right or wrong. I'm just going to plug one in here so that you see, sorry, that's incorrect. It gives you the right answer and shows you what you answered and tells you a little bit about it, what to remember, and also reminds you that you should be multiplying the coordinates by 2, what you need to do. So it does give you feedback just like we had with Delta Math. So as always, if you have any questions or concerns, please reach out and we will chat. Have a great day. If you are one of my in-person kids and you're watching this, then you need to complete the paper version that's in, and then bring it back to class with you.